So hopefully you're beginning to see how this process of testing theory against experiment or observation works in science. Now we're going to apply this framework to look in a bit more detail at one of the most profound discoveries of the 20th century. These are the results of a study by Edwin Hubble. Each one of those points represents a galaxy. I've drawn a simplified version of Hubble's original diagram here so that I can explain a little bit what it actually represents. So this axis along here is distance. This is the distance of every single one of these galaxies from our position in space. This axis here is the velocity, whether that particular galaxy is moving towards our position in the Milky Way galaxy or whether it's moving away, and whether it's moving very fast or whether it's moving much, much slower. We notice two different things. First of all, there are very few galaxies which are moving towards our own galaxy. Most of the galaxies that we see when we look out in the universe are receding from us. They're moving away from us. But what's more noticeable from this diagram is that the further away galaxies are moving away from us more quickly. Let me try and explain that in a different way. Here's our galaxy, and we're looking beyond our galaxy at other galaxies out in the universe. When we see a galaxy reasonably nearby, we see it moving away from us. That might be this galaxy here, for instance. Then we look in another direction and we see another galaxy which is further away. We see this galaxy which is further away moving more quickly. And in fact, if it's twice as far away, we see it moving twice as fast. And let's imagine that we then see another galaxy even further away. What we see then is a galaxy which is moving even faster. So you may think that when we look out at each of these galaxies, and each of them is moving away from our galaxy while our galaxy appears to stay still, you may think that this means that there's something very special about our galaxy. Our galaxy stays still, all of the other galaxies are moving away from us. But actually we don't really have any frame of reference which tells us which galaxies are moving and which aren't. So in this case, our frame of reference is our galaxy here. Let's imagine that instead we're viewing it from the point of view of some people living on this galaxy. What do those people see? What they see when they look at this galaxy is a galaxy moving away from them. But they don't see it moving away from them quite as fast as we do, because they already have a bit of movement in that direction. So that the velocity that they see is this velocity that we see minus their own velocity. What do they see when they look at our galaxy? Well, they see our galaxy moving away from them. So the speed that they see us moving away from them is the same as the speed that we see them moving away from us. How about this galaxy here that we see just moving very slowly away? Well, they are moving more quickly with respect to this galaxy. So when they look at this galaxy, they see a galaxy moving away from them very quickly. What does this tell us? It tells us that no matter where you are in the universe, you see the same thing. You see nearby galaxies moving away from you more slowly. You see far away galaxies moving away from you more quickly. We don't have any single frame of reference which tells us who's moving and who isn't. And so the idea of the center of the universe, the idea of anywhere in the universe being the center where it all began or where we all draw our frame of reference from, doesn't make any sense in the Big Bang theory. Now, this is one of the most difficult concepts in the course, so it may take you a little bit of time to digest. Feel free to watch the video again, draw your own diagrams, and if you're finding it still a little bit tricky to understand, maybe talk to each other in the forums.